Welcome, students, to another episode of Geometry with Mr. Selby. Today we're going to be learning about angles. So we're going to start off with a little bit of angle vocabulary, and then we'll move on from there and hopefully start naming angles and such. Don't forget, if you have any questions or anything, you can always message me on Schoology. You can always send an email, or you can come to office hours, okay? All right, let's get started on some angle measure. So last unit we measured line segments with distance. We also have done segment addition postulate in the unit before that. Now we're going to measure and classify angles. So we're going to use a little bit of addition with angles, similar to a segment addition postulate. We're not going to do that today, but that's coming up in the future. We're going to build on the segment addition postulate with the angle addition postulate. All right, but today we're going to focus on classifying angles. All right, we're going to identify and use congruent angles in the bisector of an angle. All right, let's get started with it. New vocabulary, ray. All right, so a ray is similar to a line. It has an endpoint though, and then it extends forever going in one direction. All right, we have opposite rays, angles, sides, vertex, interior, exterior, degree, right angle, acute angle, obtuse angle, angle bisector, and that is actually all we're going to learn today. Hopefully we'll get to all of it. Let's see what we can do. I'm going to take a break from the PowerPoint for a quick second. And you guys all have this available. This is the textbook, a little copy for you guys. All right, so a ray is a part of a line. It has one endpoint and extends indefinitely in one direction. All right, so there are a bunch of rays actually shown here. One ray is MP right here, and this starts at M and goes this way. You could also have a ray called OP, all right, which would start here and go this way forever, all right? So a ray has an endpoint. It could be M, it could be O, it could even be P here, all right? And then it goes in the other direction. It goes in one direction forever, all right? It is named always starting with the endpoint, all right? So if we started here and went this way, it would be, you could call it ray MO, ray MP, but no matter what, it has to start with M, because that would be the endpoint. If O is the endpoint, it would have to be OP, all right? It'd have to start with O. So as you can see, there's a bunch of different ways to write a ray MP, MP with a little ray signal on top. As you can see, it's a little bit different than a line, all right? There's ray MO or MO with the signal on top, all right? So just learn what a ray is, and funny thing about angles is that they actually have two rays, all right? And they meet right here in the middle, which is called a vertex. So the sides of an angle are actually rays, all right? So this ray right here would be XY, all right? As you can see, it starts here at X and then goes through Y. We always start with the endpoint as we're naming the ray. This would be ray XZ, all right? As you know, we start with X, all right? So let's keep going for opposite rays, all right? So we have a line right here. We can call this line HK, HJ, JH, JK, or KH, all right? A lot of different names for this line, or we could even call it line L. But it also has rays inside of the line, okay? For instance, you could call this ray JK when it starts here at this endpoint and then goes this way forever, all right? That would be ray JK. We could also have ray JH, which goes this way forever. Starts at the endpoint J and goes this way. We could have ray KJ, which goes this way forever. Starts here at K and goes this way. We could have ray KH, which is the same exact ray. All right. HJ goes this way forever. HK goes this way forever. It's the same ray. All right. But we have opposite rays on this as well. Okay. So ray JK and ray JH are opposite rays. They both have the same endpoint, which would be J, all right? And they go in opposite directions. So see where it says JH and JK are opposite rays? So both rays share a common endpoint, J, and they are collinear. They're on the same line, all right? So an angle is formed by two non-collinear rays, so they would not be opposite rays, hence why X is here, that have a common endpoint. The rays are called sides of an angle, and the common endpoint is the vertex, all right? So when they share an endpoint right here, that's the vertex. These rays are the sides, all right? and then we have we always use 3 letters to name an angle, and we always have the vertex in the middle. All right. So as you can see, we could call this we could call it angle X if we wanted to. We could always name with just the vertex. All right, that gets a little confusing here because as you can see, there's actually 2 angles here. So if you called it, or actually there's many more angles up here. So if you called it angle C, you don't know if you're talking about BCE or KCG. All right. So here, this angle could be called angle X, right? Because it's the name of the vertex. There's also, you could call it angle YXZ or angle ZXY. All right. And when it has a little number in there like that 3, you could also name it by the number, which would be angle 3. All right. So there's interiors and exteriors of a line. Okay. So just looking at this, we have a interior angle, and then there's the exterior angle. As you can see, the interior is in the darker blue, exterior is in the lighter blue. All right. And then, so this kind of demonstrates right here, use the map of a high school shown. This kind of demonstrates all the different ways that angles could be shown. All right. So I'm going to try and draw here with this for a little bit. So as you can see, this could be an angle right here, BCG. All right. You could also call it angle C. All right. Or you could call it angle 5, or you call it GCB. All right. BCG or GCB. Either one works. All right. Or you could call it angle 5, as you guys can see the 5 in there. If you called it angle C, there's a lot of other angle C's. It could be right here, this angle. It could be this angle right here. Or it could be this angle right here. All right. There's a lot of different ways that you could have that could be angle C. All right. That's why it's best to name angles. Oh, that eraser did not work out so well on this one. That's why it's best to name angles by using 3 letters, okay? Or it's really good to use angles when they have a number here. So like angle 3 would be perfect for this, all right? So if we look at this, we can name all angles that have B as a vertex, okay? So ABD is 1. You call that angle 1, all right? And then CBD is 1, and that could be angle 2, all right? So either one, all right? Also, in addition, you could name this DBA, or you could name this CBD, all right, or DBC. Either one works, all right? Name the sides of angle 3. So as we can see, this one's angle 3 right here. So the sides of it would be ray CCA or ray CB, okay? Or you could call it ray CE going this way, all right? Lots of different options for that. Another name for GHL. So GHL right here. You could call this angle 7. All right, I'm a big fan of just naming it by the number. Okay, you could name it angle H, which I don't think is a great option here, but you could do it. Or instead of calling it GHL, you go backwards. You go LHG. All right, either one works. All right, and then name a point on the interior of DBK. So DBK is right here. All right. And a nice interior point would be point C. So as you can see, DBK is this right here, and then point E is on the interior right there. All right. So let's go back to the PowerPoint for a quick second. Actually, one more thing is that angles are measured in units called degrees. So as you can see, there's a circle right here. The circle is divided into 360 different parts. Okay. Those are called degrees. Normally, angles are 180 degrees or less, all right? So we typically measure them using a protractor, all right? And degrees signify what kind of angle it is, okay, and how large the angle is, all right? So you can have angles that are about 10 degrees, which are small. This angle appears to be about 50 degrees, okay? All right? We'll go a little bit more into that later on. Let's head back to the PowerPoint really quick. All right. So we went through all of these except for right angle, acute angle, and obtuse angle. All right, we'll do this in a little bit. And angle bisect we did not get to yet. All right, name all angles that have B as a vertex. Okay, so as you can see, angle B is, or point B is right here. All right, oops. All right, so we could name it right here. Angle 5 has B as a vertex, okay, with GBE, so angle 5. Angle 6 has B as a vertex with EBD, all right, so angle 6. Angle 7 has ABD, all right, B is the vertex in there. And then the last one, this could probably be like angle 8, but there's no number on it, all right, but it's GBA or ABG, all right. So 5, 6, 7, which we named, and then ABG, all right, so those 4 angles all have B as a vertex. All right, name the sides of angle 5. All right, so there's a lot of different names for the sides. There's only 2 sides of this angle right here, and it's this side, which I would name BG, okay, and then there's this side, which you could name BE, BF, all right, a lot of different names on those. So 3 different names, so I guess it really wasn't a lot, but 3 different names. Essentially, as long as the endpoint is always the first letter for the ray. Okay, so this is a ray right here. This side is a ray, BG. B is the endpoint, all right, and then it goes all the way this other way. So B must be first. B is also the endpoint going this way. The vertex must be first when you're identifying the sides. Vertex is always in the middle when you're identifying the angle. All right, write another name for angle 6. Okay, so there's 3 other names I can think of right off the bat for angle 6. You could call it angle B, which is just the name of the vertex, right? Always name the angle by the vertex. Not a very specific name, so I wouldn't recommend it, but you could do it. Then you've also got EBD, all right? Right here, EBD, okay? You could also call it DBE, right? DBE. B is the vertex in the middle, identifying with points on both sides, all right? Now, this one might be a little bit of a wild card, but you could also throw in there FBD, okay? FBD, or DBF, all right? So it would be 5 names. Let's see how many they have on here. They only have 4. Because they did not call it angle B. All right. Which angle has point X as a vertex? All right. So why don't you guys take a second, go ahead and pause the video if you need to, and go over which angle has point X as a vertex. All right, so let's go through all of these, and hopefully you figured out the correct answer. So really fast, I told you, I don't know if you guys remember at the beginning, but I said that the vertex must always be the middle letter, okay? So this one, the vertex would be B. All right, so we know that's not right. This one, the vertex would be A. We know that's not right. This one, the vertex would be A. Also not right. This one has the vertex as X. So this one must be the correct answer. Let's see. All right, perfect. So you can look at this straight up and just say, this one's got to be the correct answer. This is the only one with the vertex of X. All right, but let's go look through and see what these other angles are. So you got X, B, Y right here. So this must be this angle right here. All right. Again, the vertex here is B. Don't want that. YAX, YAX. We got YAX. It would be right here. So the vertex here is A. We don't want that. RAD. All right. A is, again, the vertex. Don't want that. That's actually the same angle as YAX. All right. AXB would be AXB. So this must be our vertex, and D is our correct answer. All right. Which ray is a side of angle 3? Why don't you guys take a second, go back, review a little bit, see if you can figure this one out. Go ahead and pause it. All right. Let's go through this for just a quick second. All right. Which ray is a side of angle 3? So angle 3 is right here. The vertex is X. All right. So we know that our vertex is X. That must mean that the endpoints for both the sides must be X, which means that the ray has to start with an X. All right. So RA is not, I mean, I guess you could say that is a side, but it's not because it ends here at the vertex. So that would not be the correct answer. Okay. Xn right here is a side of angle 3. Like it starts here at the end point, which is x. All right, and it goes past, goes through what the angle would be. AY, not even. I mean, it intersects with the angle, but it's not a side. And then none of these. So it would probably be XN, which is B. All right. Again, if you had any questions or concerns with this, please message me on Schoology, email me, or come to the Zoom office hours. All right. I hope everybody is staying happy, healthy, and hydrated and safe out there. And hopefully I will see you guys again soon. All right. Have a good day, guys.